Greetings Earthlings, let's start 1, 1, 2, 3, 5 and so on. That's Fibonacci sequence. Two previous numbers adds up and give next number. A spiral made from this sequence is called a Fibonacci spiral. What's special? Golden ratio, and what is it? Simply represents the most irrational number possible. It is the hardest number to approximate with a simple fraction. It's commonly seen among the organic life forms mostly. It helps them pack things efficiently. But how does it relate to golden ratio? When you divide a Fibonacci sequence number with 1 before it, as the number gets larger, this doesn't spit random numbers. It zeroes on a highly specific irrational number, which is golden ratio. But how was it discovered? Nobody actually discovered it. It was conceptualized over millennia. Greek mathematician Euclid provided the first recorded definition of it as a line divided in extreme and mean ratio in his famous textbook, Elements. For centuries it was sitting dry in textbooks, but in 1509 an Italian friar and mathematician named Luca Pacioli wrote a book on it and named it The Divine Proportion. To make matters better for its fame, he had his close friend illustrate the book, Leonardo da Vinci. Once da Vinci's name and the word divine were attached to it, the ratio stopped being just math and started being treated as a secret code from God. The real modern worship started in the 1850s with a German philosopher and psychologist named Adolf Zeising. Zeising became obsessed with the idea that the universe must have a single underlying law of beauty. He declared that the golden ratio was this universal law, governing everything from the human body to ancient architecture. His book was built on fabricated data, retrofitted history, and mathematical impossibilities. He asserted that the golden ratio was a universal law of nature and art, but to prove this, he notoriously cherry-picked and manipulated anatomical measurements of the human body, shifting his physical anchoring points arbitrarily from hairlines to chins, just to force the math to match a perfect navel division. He then extended this deception to art and history, falsely claiming that ancient Greeks deliberately used the ratio to design the Parthenon by drawing arbitrary grids over photographs that ignored the structure's true 4/9 architectural fractions. Furthermore, Zeising popularized the myth that Leonardo da Vinci hidden-coded the ratio into masterpieces like the Mona Lisa. In reality, da Vinci's own journals prove he used simple whole number fractions and only ever illustrated geometric solids for his friend Luca Pacioli's book. Zeising even bungled basic biology, confidently mislabeling the chambered nautilus shell as a perfect golden spiral when its actual growth ratio sits nowhere near 1.6 But his book still became incredibly popular, and the myth that 1.61 universal beauty was cemented in the public mind. But the term golden still wasn't coined. The actual word, golden, didn't appear in print to describe this math until 1835. A German mathematician named Martin Ohm used the term goldener Schnitt, a golden section, in a textbook. He noted that people in his circles were starting to call it this. But why? Geometrically, it is the only ratio where dividing a line creates segments that perfectly mirror the proportion of the whole line. Just as gold has universally represented the most precious, pure, and flawless metal across human history, the word golden was frequently used in German intellectual culture to denote the absolute highest tier of perfection in a specific field. By the 1800s, math education was transitioning away from religious framing. Ohm wanted a secular term that retained the prestigious status of Luca Pacioli's divine proportion, but grounded it purely in academic and geometric excellence. The reason you hear so much about the golden ratio today is because we are still dealing with the cultural fallout of Zeising's 1854 confirmation bias. But is it really divine? The Fibonacci sequence is mostly seen among the living things, at cosmic scale, and in overall nature. Shapes like circle, hexagons and Voronoi patterns absolutely annihilate and dominate the Fibonacci sequence. But why does nature seem to love some shapes over others? It comes down to a fundamental rule: working in most efficient way possible while spending minimal amount of energy possible. It hates even spending an extra penny. It's that perfect. Nature is pretty adaptive. When living things need to survive, they want to pack things in a shape that guarantees least amount of loss. At cosmic scale, the sphere is the undisputed champions, but among livings, especially among plants, living things grow outwardly from a central point, like the tip of a stem, called a meristome. They aren't trying to compress mass. They are trying to maximize access to sunlight and minimize crowding for their seeds or leaves. Because plants grow sequentially as one seed leaf after another, they have to rotate to place the next piece. As we saw earlier, rotating by the golden angles 137.5 degrees creates a Fibonacci spiral, though imperfect, which is mathematically one of the only way to pack things together without creating overlapping straight lines or giant empty gaps. Fibonacci is the champion of living things because it solves the problem of sequential growth in a crowded space. If spheres and spirals are so great, why does nature sometimes abandon them for hexagons or branching fractals? Spheres are great for saving surface energy, but they are absolutely terrible at packing together. If you put a bunch of spheres in a box, there is always empty space between them. When nature has a bunch of circular things that are forced to squeeze together on a flat plane, they crush into hexagons. So saying Fibonacci sequences proves existence of creator is equivalent to saying circles prove the existence of a creator. But the conclusion is that it proves nothing. The fact is we humans love finding patterns. Our brain isn't a supercomputer, but a pattern-recognizing machine. The fact is that Fibonacci spirals look beautiful because they're predictable and are symmetrical. The golden ratio creates self-similar, repeating geometry fractals. Because the math scales perfectly, your brain can process a massive amount of visual information incredibly quickly, without any cognitive friction. When your brain successfully processes a perfect pattern, it starts experiencing this effortless processing as satisfying. That feeling of satisfying, frictionless processing is what we call beauty. We aren't recognizing magic, we are just enjoying an easy puzzle. And when we see something perfect, we start thinking there should be an intelligent creator behind this because it has an intelligent design. But then we forget that we exist to notice any of this, because a universe without stable rules produces no observers to question it. Fibonacci doesn't prove a creator. But it doesn't disprove one either. It just proves nature is extraordinarily efficient and that we really enjoy watching it be.